Hi students, let's look at this question here, which is on summation. Let's say you can do this proficiently, taken from the year 2007 Hua Chong HCI lecture test question 6. Okay, it's modified. Verify that for any non-real real constant m, that this is equal to this. I think this is pretty okay. Just gonna verify it. So copy the one on the left and show on the right that is it. I think it shouldn't be an issue there. So just copying down. So what we're going to do next is just make it the common denominator. That will be 1 over m multiplied by mr plus 1 minus mr plus 1 minus m over mr plus 1 minus mr plus 1. Okay, I think shouldn't be an issue there. Then the numerator, what we'll get is actually, you could just skip step. So I'm going to skip it. mr plus 1, that will be mr minus 1. We're left with just m above, so this will cancel away and that will be just this, right? Shouldn't be an issue there. Plus 1, verified. Okay, now then after which we're going to do part 2, hence show this is equal to this. Now what we need to understand is actually I think the idea here is very important. You must be able to tell that this guy here is actually r minus 1 plus 1. Okay, so you can read this as this. Okay, this is important because it's actually if fr is equal to mr plus 1, then fr minus 1 is actually mr minus 1 plus 1. So that's pretty okay. So what we're going to do is actually just I'm just going to continue on this side here. So part 2, show, so summation equals to 1, then after which we have got mr plus 1 minus mr plus 1. So for summation is very standard. You typically only have 3 ways to solve it: AP, GP, or method of difference, right? So that's all in your syllabus. So what you do is, this case here, we're gonna use this guy here because this is basically just what do you call it, the neighboring terms. Okay, they are neighboring terms. So this case here, from the first part, I know that this is 1 over m, bracket it out, mr plus 1 minus mr plus 1. Okay, so I'm going to bring this out just like I said. Usually what I like to do is r equals to 1, then this is mr minus 1 plus 1, then this is mr plus 1. So I'm going to let fr equals to 1 over mr plus 1. So fr minus 1 will just be mr minus 1 plus 1. So this is easy because I don't want to keep rewriting everything. So this will just be m and r equals to 1, and then that will be fr minus 1 minus fr. I think this is easier to deal with. So what I will do is m, then there will be f0 minus f1 plus f1 minus f2, then f3 minus f2 minus f3, and so on to the last few terms. Second last term is m minus 2 minus, just usually what I suggest is the last last 3 terms, but in this case here I think last 2 terms will be okay also. So plus fn minus 1 minus fn. Okay, there you go. So once this is done, we can continue. This case here, we're just gonna telescope it in cancel method, what do you call it, method of difference. So that would be 1 over m f0 minus fn. Okay, so f0 will just be just substitute this in, that will be 1 over m. This is 1 over 0 plus 1, so it's 1 minus of m n minus 1 plus 1. Okay, it's what asks us to show. Okay, great. So now I'm just gonna make this as single fraction. Okay, so that will be mn minus 1 plus 1 minus 1 over mn minus 1 plus 1. Okay. I think I substituted the wrong info in, so yep, that is the mistake there. So substitute into this, should substitute into this. I substitute the second one to the second one. So this should be f0 will be 1, 0, plus 1, plus minus of n. Yeah, there you go. This is much easier. So this is the correct one. So this will be mn plus 1 minus 1 over mn plus 1. Then that will be mn on top, mn plus 1 below, and this will be 1 over m. Cancel this up. That will give us n over mn plus 1. Okay, so I think this is pretty okay. Great. Write this down. The last part, part 3, what we need to do is to understand that okay, the main thing is you have to be able to relate 1 3 1 4 3 5. Actually it will correspond to the what do you call it, the denominator here. Okay, but it may not be so straightforward. So what I will suggest is understand that mr plus 1. Okay, so for example, if this is an odd number 3 5 7, okay, I could see that actually there are two series running here. Okay, because 1 3 3 5, this will correspond to each other, whereas 1 4 4 7 7 10, that will be correspond to the other one as well. Okay, so basically for odd terms, we know that they are 2r plus 1. Okay, so I could use that because m is for any real constant. Okay, just right. Okay, so this is what I'll do. I'll just bring this number 3 down. I know that I've got 1 times 3 plus 1 4 plus 1 3 5. You can just write the summation out. Then plus 1 5 7 plus 7 10. Then to the last n here will be 39 times 41 plus 1 over 58 times 61. Okay, great. So this case here, I could write the summation. This is 1 2r plus 1 2r plus 1 2r plus 1. Okay, then for the second one, you could see that actually is 4 increment of 3. So I'll just write it down. This is increment of 2. This is plus 2, right? This is plus 2, right? Here to here is plus 2. Here to here is plus 2 as well. Okay, great. Then from here, the subsequent one, so there are two series here, plus 3. This is plus 3. This is plus 3. And this is plus 3. Great. So I don't. So we're gonna. I think I will presume this is odd. Am I right? Odd. I'm not sure where the is stop, but we need to check later. So firstly, I'm just gonna group them. Actually, we could just quickly check whether 39 is belongs to the green or the blue one. So I'm just gonna take let's say 7, then just keep adding 7, right? Keep adding 3. 1 2 3 4 5. Okay, this is a faster way so that I'm a bit lazy here. So 39 doesn't belong to the 58. Does it belong to the 58 one? Okay, I think it does. Let's see. 61. Oh, this is until 61. So the blue one belongs to the 61. Wow. So I guess the green one belongs to the 39. Let's look at the 39. Is it 39? So we have got 5 plus 2. I think so. It belongs to 39. There you go. So this belongs to the green one. Okay, great. So now why do I do that? Is because I could write down the two series together. So I have got 1 times 3. Now let's just assume that we wouldn't know. We just need to write this in series form, right? So meaning, so this is 1 series. Then after which you have the other one, which is the blue one, which is 1.4 plus 4.7 plus 7.10, okay, plus 58 to 61. Okay, there you go. Now, how do we do that? So we need to write the series down. This case here, we know the odd number. We know the odd number is just, let me just write it down. FR is equal odd number. Okay, let's say this is FR is just 2R plus 1. Okay, because we have 2R plus 1, right? 2R plus 1, 2R plus 1 minus 2R minus 1 plus 1. Okay, great. 2R plus 1 here. So I'm going to write this down. So I'm going to sum it from, generally this is what? MR minus 1, is it? We need to use this MR minus 1, MR plus 1. So this is the larger one. This is the smaller one, right? Yeah, this is the smaller one. So MR plus 1 should correspond to this one here. So it's actually 2R plus 1 over here. Then that will be 2R minus 1 over here. Okay, so this is where if my FR is FR, this is okay, let's say this is UR here. 2R minus 1. This is 2R plus 1. Okay, this is actually my U1. U2, because you sub into this, you will get that U3. So I know that I keep adding, right? U2 would be 3 and then 2, then so on. Okay, so this is U, you could check for R equals to 20, yeah, RU20. Okay, so there's U20. So this is R equals to 1 to 20. Here you go. So we could actually use this juncture here, because very clearly the M here is actually, this is M equals to 2 increment, right? From 2, yeah. So the increment for the subsequent one would then be let's look at that. There will be plus 3, plus 3, plus 3, plus 3, right? Okay, so same thing, we need to be able to see. So the increment, just like in secondary school we learn, the UR here, general pattern here will be UR is equals to, because it's increment of 3, so it's 3R plus 1 and 3 R minus 1. Plus 1. Okay, it's a one term before it. So there'll be, yep, there you go. This is U1. This is U2. When this is 2, you will get 4. When this is U3, you get 3, 2, 6, 7. Yeah. So this is U, is it 20? Because this is 20. Yeah, it's a U20 here. So 20, 19 times 3. There you go. So this is U20. So to rewrite it in sequence form, I will get R equals to 1. This is 20 as well. So this is 3 R minus 1 plus 1. This is 3R plus 1. Okay, there you go. Now this case here, we know that very clearly. This from the previous part is M equals to 3. Okay, these are the M. 2R minus 1. Actually, some would ask, actually this is the same as 2R minus 1 bracket the whole thing. So let me just write it down, this one, this case here. 2R minus 1 minus 1, 2R plus 1. They are the same. This is the same as this one, okay? So there you go. We write this down. So from the previous part, we know that this is N over Mn plus 1. So the previous part, I'll get this as 20 because the N is 20. So the M is 2. 2 times 20 plus 1. Then this case here, there will be 20. M is 3 and this is 20 as well, plus 1. King calculator. That will be your answer here. 20402501. Okay, great. So I'm just write this down. This is 20402501. Okay. So that's how I do this questionnaire proficiently. If you have any questions at all, please let us know and I'll see you in the next question.